there's not really any calculations to do here, but there is some knowledge to have. Okay. Skew lines seem to mess people up every year. So if you already are comfortable with what a skew line is, you're in pretty good shape. If you're not, here is your chance to learn it and get very good at it now. So I want to letter these here. You have this set up, so follow me, follow what I do and make this one A and that one B. So that vertex is A, this one is B, this one over here is C, and this one here is D. A, B, C, D. On the bottom, I want to do the same thing. A, B, C, D, but then this is going to be E, F, G, and H. So I'm a pattern person, routine pattern person, so I'll go in this direction that way, and I'll do the same thing down here. Okay. So what we're going to talk about is what skew is. You already know what parallel lines are, and parallel planes I'll go over after skew lines, but I want to focus on this first. Skew lines are lines that are not parallel and don't touch at all. So it's two things. They're not parallel and they don't touch at all. So in other words, you're going to have two lines that are not parallel, but they could be going like this, so they don't touch you. They're not parallel, but they still don't touch. That's because they're in different planes. So let's take AB here. So what I want to do is figure out lines skew to AB. So the lines that are skewed to AB are lines that are not parallel to it. So EF is out, DC is out, HG is out, and they don't touch it. So BC comes this way and it touches. If I kept the line AB going, well, even if I don't, it does touch it right there anyway. So BC is no good and AD is no good. They're not skew lines. Okay? But look at F to G down here. This one down here is not parallel to AB and it will never meet it. It's completely separated from it. It's like AB is here and the other one's going this way. Completely separated from it in these two ways. Not parallel, doesn't touch it. So that means the line FG, and over here line EH. And then when I look at the others, you think about D and H, these ones here, this one and this one, they are not parallel to AB, and they are going to go up and down like this, and they're never going to touch AB. So that means that DH and CG are skewed to it. So when I ask you on the test in a few weeks, from some figure similar to this, what lines are skewed to something like AB, you need to be able to tell me that. All of them, all four of them. There happens to be four. When you have a rectangular prism like this, what this is called, a cube or three-dimensional figure like this, you're going to have pretty much four of them all the time. Because you'll have two down here, or you'll have two over here because of that one. But now let's change it up. Okay. I started out by saying, oh yeah, well for FG, then AB, these are off. Well, let's take FG and let's find all the ones that are skew to FG. So if FG is here, well, this one's parallel, this one's parallel, this one's parallel, this one touches it, this one touches it, this one touches it, this one touches it. But for this one, it looks like D to H doesn't touch it, and A to E doesn't touch it, and they're not parallel to it. So D to H, A to E, okay? And then since that one's in the bottom, if I come up here, it looks like this one going this way, and this one going here, like AB, as we already know from this one that they're skewed. And CD over here. So I look at this one and I figure out which ones are not parallel to it and are not going to touch it. I would like for you to do that now. I want you to write down the lines that are skew to DH. Find DH there. Write down the four of them that are skew to DH. So they're not parallel to it and they won't touch it. Don't touch the corners of it, or the vertices. You should have figured out those four. It doesn't matter what order they're in. Even the letters. I prefer and recommend that you put them alphabetical order whenever you write them. But it really is not essential. Just make sure you have the right ones. Okay? So that's what you should have had for DH. So for DH, the EF here and AB, and then the FG and the BC, the ones farthest away from it, essentially. Okay. Now let's talk about parallel planes. Of course, as you know, not planes that are flying around in the air, but rather planes like a flat board is a plane. And so when I did A, B, C, D, this top part of this box is a plane. When you come down to the bottom, you have the same kind of plane for E, F, G, H, because they are parallel, not just the lines. AD is parallel to EH, and as well as BC and FG. So the four of those are all parallel. But what you get here is basically a box top and a box bottom, and if they're cut correctly, that means that they are parallel to each other. So I'm going to say A, B, C, D is parallel to E, F, G, H. You are used to using parallel for just lines. Yes, we can say it for the four of them together to say that it's a plane. In fact, even three of them alone would be able to designate a plane. If I just said A, B, C, because the three of them make a plane, they can't be like separated from each other. That would be enough. But we have this already as four, so I'm going to say that. And now if I look at another one, I can look at, say, the side one here. If you think of it as a box, I have a side one here, and over here I have a side one too. So A, B, F, E, or A, B, E, F. I think I'm going to go in order here, so I won't care about the alphabetical order. A to B, F to E. So A, B, F, E is parallel to the other side of the box, D, C, G, H. And there's one more set of planes that are parallel. I want you to write it down yourself here. Write down what the other set of sides are. If you think about it as a box, there's two other sides, one pair, that are where as sides or as planes that they are parallel to each other. You should already have figured that one out. So A to D to H to E, you think about that as the front of the box, and then B to C to G to F, that's the back of the box. Those are parallel too. They'll never touch each other, right? So what you have then are three sets of parallel planes. That covers all six sides for this. So it's a concept I just want to make sure everybody is good and comfortable with. Now let's look at page 2. This is going to connect in with section 3 in just a moment, or section 11.2 in just a moment, rather, because vocabulary phrases you need to know. Now, I believe that you touched this also in the Common Core Math 7 class. I'm trying to remember, because I used to teach that, but it's now been a few years. But I know that you should recognize alternate interior, alternate exterior, corresponding angles. Well, we're going to review them because they're going to make a big deal of them in the next section. Yeah, to this. So you should have seen these before, because yes, I guess it was Math 8. So we're going to talk about relationships of the angles. But here's the thing. None of these are going to matter unless X is parallel to Y. Those two lines have to be parallel Well, I guess they don't for the relationships, but they're going to be, you basically need to know that they're going to be for all the stuff we're going to do. Okay, and I'll talk it through in the next section. So I set this up so that they're parallel, and this line that goes through here, I'm going to call it line A. Line A is a transversal. Oops, I forgot the R. Transversal. A transversal, it cuts through two other lines. Okay? Not just one. If it was just one line that cut through it, it would just be two lines intersecting. But when it cuts through two lines, it's a transversal. Now, when you get that, whenever you get that, that means automatically the two angles here are a linear pair. A linear pair, or supplemental, these essentially mean the same thing, means that whatever angle plus whatever angle automatically adds up to 180. So, might as well number these. Did I do that on my notes? If not, let's go ahead and do it. Let's do 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8. Okay. So let's say angle 1 and angle 3, they add up to 180 because they make a straight line. So a linear pair has the word line in it, so it makes sense. It makes a line. So that's one way to remember it. It just makes a straight line. And so 2 and 4 do the same thing. They add up to 180. 1 and 2 adds to 180. 3 and 4 adds to 180. And the same thing with the ones down there. Okay. Vertical angles. Now this is actually in one of the sections that we skipped at the end of chapter 10. You'll notice if you had been doing the book, there's like a section 10.8 or so. There isn't anything in there that we needed to do this year, and for numerous reasons, but we've got some other stuff we want to do, so I skipped those. But there was one thing in there that I need to show you now, because we're going to use it, and that's vertical angles. The vertical angles are when you have an intersection, the ones across from each other automatically equal each other. So in this case, that means angle 2, the amount of angle 2 is equal to the amount of angle 3. So those two are vertical angles. So are 1 and 4. So are 6 and 7. So are 5 and 8. So if I knew that angle 2 was, say, 140 degrees, I would immediately know that angle 3 was the same thing, because they are vertical angles. And in fact, that's considered an acceptable reason to say that 3 is 140. If 2 is 140, then because 3 is a vertical angle, that's my reason, my acceptable reason or proof that angle 3 is also 140 degrees. Okay. Now, corresponding angles has to do with the separate intersections. Okay. We have an intersection here and an intersection here. Think of it as like roads connecting, so that's why I call them intersections. And look at where 1 is placed. Angle 1 up here is in the top left part of this. When we come to the other intersection, angle 5 is in the same placement area. It's in the top and on the left side. So 1 and 5 are considered corresponding angles. You have to get used to that term. You're going to see it in a number of ways. So just make sure when you see corresponding, or if you have to say why 1 and 5 are equal to each other, the reason is because they're corresponding. So get used to the word. If you aren't already, get used to it. So I'll say angle 1 is equal to angle 5, or angle 1 and angle 5 are corresponding, but if they're parallel, they're equal. Now, if these weren't parallel lines, I'd just say that angle 1, comma, angle 5 are in the same placement area. They would be corresponding. But because they're parallel, that means that they actually have the exact same measurement. But they have to be parallel to do it, X and Y. So there's a bunch of others corresponding, 2 and 6, 4 and 8, 3 and 7. If you've got the concept down, you don't have to write them down. Just make sure you get the concept. Okay. Interior and exterior seem to get some people mixed up every year. You want to think about these two lines as borders. So if X is going there, the in between them is the inside of the interior. So that means these are interior angles. And sort of the opposite, exterior angles are the ones outside of it. I don't think I really need to spend any more time on it than that. Just remember those words, interior and exterior, as inside and outside, or exit for outside if you want to. Okay, now here, these ones, we have to make sure you're comfortable with the meanings of those. And then the next section, we actually will do little equations and match things up. Consecutive interior, let's break that down. Interior angles, and consecutive means that they're going together with each other. Well, with consecutive interior angles are angles like this that if you were going along the line, it would be 3 and then 5, and they're interior. So 3 and 5 are in consecutive interior. 4 and 6 are consecutive interior. So we'll say angle 3 and angle 5, and separately angle 4 and angle 6. Those are consecutive interior. It just so happens that if these are parallel lines, then these two would add up to 180 degrees, and so would these two. Okay. Now, alternate interior and alternate exterior, interior and exterior, you recognize that. Alternate means opposite sides here. So what that means is that 4 and 5 are alternate interior. I'm going to emphasize those, and 3 and 6 is alternate interior as well, where they're inside and they're on the opposite parts of each other. These are a big deal because they seem to be the ones that people tend to get mixed up more than any of the others. Okay, they mix up what to do with them, and they mix up which ones they are. But visually, you can see that they're interior and they're like opposite, and it means if these are parallel, then the amount of angle 4 is equal to the amount of angle 5. And set 3 is equal to 6. That's going to play a part in the next section, the tests we do, and you're going to find out that you're going to work with that in a number of other problems when you get into, we're going to use it, some of the word problems we've got coming up, some of the application problems. And when you get even into pre-calculus, we use that as just part of a bigger problem. You have to recognize that you have like roads or something, and they're parallel, and then the amounts, you have a line, another road going through them, and that means certain parts you know the measurements immediately of the angles in it. So we'll be playing with that later. Alternate exterior is the same idea. If alternate interior means 4 and 5 are the same, well then let's take, well, we'll go to 1 here. Angle 1, we go to the other side, but we go opposite of it. So that means 1 and 8 are alternate exterior. I suppose I should write it so you can read the word. 1 and 8 are alternate, and they're exterior, and 2 and 7 are also alternate exterior.